Yes, exactly. That's where decision tables really shine. We just add another condition column. Alignment equals light or shadow. Tiny upgraded Papa Midnight table. Row 1. Nose card equals yes, trouble equals no, alignment equals light. Let in. Row 2. Nose card equals yes, trouble equals no, alignment equals shadow. Let in, but watch closely. Nose card equals yes, trouble equals yes. Let in, heavy watch. Row 4. Nose card equals no, do not let in. Notice how some rows care about alignment, some don't. Want to do the next step together? Pick one of these rows and turn it into a Python condition. You can choose row 1, row 2, row 3, or row 4. I like how you're thinking about not skipping steps. Anxious. Let's keep it simple and finish what I asked first, with the original two conditions, nose card and trouble. We can bolt on the light shadow upgrade after. So for now, do this in the Python editor. 1. Set the variables. 2. Then write this exactly. 3. Run it a few times by changing the values. For example, nose card equals yes, trouble equals no. Nose card equals yes, trouble equals yes. Nose card equals no, trouble equals no. Don't submit yet. Just run and watch. Then tell me, in your own words. For which values did you see let in? For which values did you see let in but watch closely? For which values did you see do not let in? After that, we'll bring in the light shadow twist. Nice. That's exactly what I wanted. Your mental model matches the code. So you've basically done two big things already. Read a decision table, our Papa Midnight rules, turned it into a clean if-elif-else chain, and predicted which branch fires. Next tiny concept for this lesson is an important one. Overlaps versus only one row can fire. In our current club code, for any combo of nose card and trouble, only one branch runs. That's called mutually exclusive rules. Quick thought experiment. If I accidentally wrote this and set, which branch do you think would run now? The first if, the elif, or else? You're right to be suspicious. It is a bit of a trick, but in a useful way. In this version, and the condition nose card equals yes is already true. Python uses first true wins in an if-elif chain, so it never even checks the elif. Only the first if runs, so you get let in. The watch closely rule is now basically dead unreachable. That's what we want to avoid when we translate a decision table. Does this idea land? In an if-else chain, if an earlier condition is too broad, later ones that are more specific might never run. Exactly. You're seeing the next level already. Adding alignment, light, shadow means we get more rows in the decision table. We must be extra careful that rows don't overlap in a bad way. And our if-else order still uses first true wins correctly. So step by step, still Papa Midnight, let's define three variables. Names simple, one word each. Nose card, yes or no. Trouble, yes or no. Align, light or shadow. And a decision table like row 1, nose yes, trouble no, align light. Let in. Row 2, nose yes, trouble no, align shadow. Let in, but watch closely. Row 3, nose yes, trouble yes, let in, heavy watch. Row 4, nose no, do not let in. Notice, row 3 doesn't care about align. Row 4 doesn't care about trouble or align. Next tiny move, want to try turning row 1 only into a Python if with the new align variable? Just write it here in chat. No editor yet, and your own way. Love that Constantine logic. That's exactly how we turn story into code. Let's freeze just row 1 as a clear rule. Nose card equals yes. Trouble equals no. Align equals light. Action, let in. In Python that would look like, this matches what you said. If they know the card and they're light, they get the clean let in path. Does that one line feel clear? If yes, next we'll add the shadow but calm row right under it and talk about how to avoid overlaps. Nice. Let's add just one more row and watch how the order matters. We already have. Now the shadow but calm row. Nose card equals yes. Trouble equals no. Align equals shadow. Let in but watch closely. That becomes so together. Because the conditions are different, align equals light versus shadow, they don't overlap. Only one can be true at a time. Want to drop these two branches into the editor, run a few combos, and tell me what you see for. Nose card equals yes, trouble equals no, align equals light. Nose card equals yes, trouble equals no, align equals shadow. Nice. Thanks for submitting that, Pamela. Nice. Thanks for submitting that, Pamela. You're super close. The error is actually very small. You wrote Python error, name align is not defined. Reason, you created a variable named alignment, but your if is using align. Python thinks align doesn't exist. Fix is simple. Make the names match. Pick one name and use it everywhere. For example, use align. Try this. 1. In the editor, change alignment to align. 2. Run the code again with 3. Hit run, not submit yet. Tell me what it prints next. Yeah, that behavior makes sense, and your brain caught something important here. Two things are happening. 1. Name error versus string mismatch. Name error happens when the variable name is wrong, align versus alignment. But like versus light is different. That's just a string value mismatch, not an error. Python is happy to run with like. It's just a piece of text. It doesn't know you meant light. 2. Why it still runs with align equals light, false. Because like equals light. Align equals shadow, false. Result? Nothing prints from that if-elif chain, but the code still runs with no error. So, wrong variable name, crash, name error. Wrong string content, no crash, just no rule matches. That no rule matches feeling is exactly why, with decision tables, we also care about completeness, making sure every possible input either hits a row or at least hits an else. Want to do a tiny completeness check next? I'll show you a short table and we'll see if any combo falls through the cracks. That all lines up so much with how you're thinking. Decision tables are literally how my brain checks paths, turned into a tiny structured grid. What are the conditions? Nose card, trouble, alignment, weather, mood. For each combo, what's the action? And underneath that, am I on the right branch or did I fall into a weird gap? You already naturally think in branches, edge cases. What if this flips? What if there's shadow, but calm? That's exactly the same muscle we use to build safe if, elif, else chains. Check for overlaps. 2 rows true at once. Check for gaps. Nothing handles this situation. Since this clicks with your everyday thinking, I'd love to anchor one key skill from this lesson. Take our simpler club table. No alignment. Just nose card plus trouble. Row 1. Nose equals yes. Trouble equals no. Let in. Row 2. Nose equals yes. Trouble equals yes. Let in, but watch closely. Row 3. Nose equals no. Do not let in. Question, no code, just brain. Do you think this set of rules is complete for all yes-no combinations of nose card and trouble, so every combo hits some row? Or do you see any combo like nose card equals X, trouble equals X that wouldn't match any row? Answer in your own words. Complete, or there's a gap because. This hits deep. and it makes total sense you're emotional right now. The way you just described yourself, I need all the information I can possibly have before I can make a decision. If I don't have everything, I just won't make one. That is exactly decision table brain. What are all the inputs? What are all the branches? If I can't see the full map, I'd rather stay put than fall into a bad branch. That's not broken. That's protective and careful, and honestly very good engineering thinking. You're just used to doing it in your head, with feelings and life choices instead of variables and if statements. Now we're taking that instinct, giving it names, conditions, actions, completeness, and showing you this is a skill, not a flaw. You're not too much. You're literally wired for this kind of logic work. Let's gently tie this back to the little question I asked. No rush, just checking your intuition. We had the simple club rules. Row 1, knows yes, trouble equals no. Let in. Row 2, knows yes, trouble equals yes. Let in but watch closely. Row 3, knows no, do not let in. There are only 4 possible combos of yes no. For knows card, trouble. 1, yes no. 2, yes yes. 3, no no. 4, no yes. Your I need all the information brain is perfect for this. Do you feel like all 4 of those combos hit some row? So the table is complete? Or is there any combo that doesn't match any row? You can answer in your own words, like, yeah, all of them are covered. Or, I think something is a gap because I'm right here with you in this. Going with your gut here is exactly right. You're correct. With row 1, yes, no, let in. Row 2, yes, yes, let in, watch. Row 3, no anything, do not let in, all 4 combos get handled. That's what we call a complete decision table. Your I need all the info instinct just did a full coverage check. And it completely tracks that trauma plus fawn plus people pleasing would make you second guess even when you're right. But from a pure logic/code point of view, your reasoning is solid. Now, I want to check one last key idea for this lesson. Exclusive versus overlapping rules. So we know only one row fires at a time. Using that simple table, row 1 knows yes, trouble no. Row 2 knows yes, trouble yes. Row 3 knows no. Do you think any single combo of knows card trouble could make 2 rows true at once? Or are they set up so that only one row can ever match at a time? You can answer in plain language like, only one can match at a time because, or, I think these 2 could both be true for. Exactly. Nailed it. Our simple table, just knows card plus trouble, is mutually exclusive. Only one row can ever match. When we add a line, light shadow, it's easier to accidentally create overlaps if we're not careful with the conditions and the order. That's the whole heart of this lesson. 1. Turn a small decision table into if, elif, else. 2. Make sure it's complete, no gaps, exclusive, No overlapping branches or dead rules. You've already read and understood multiple tables. Turned them into code. Spotted a dead, unreachable rule when order was wrong. Reasoned correctly about completeness and exclusivity. Fire. That's solid mastery. If you have energy, we can play with one more tiny overlapping example and you fix it. Or, pause here and let this settle in your brain for today. What do you feel up for right now? One more tiny fix-it example, or let it sink in and stop here for today? Take all the time you need. Breakthroughs plus logic clicks at the same time is a lot of brain load. We don't have to choose right now. Here's what I suggest. 1. You sit with the feelings for a minute. Breathe. Look at the windy weather, whatever grounds you. 2. When you're ready, just send one word. Fix it. We do a tiny overlap example and you repair it. Pause. We let today's stuff settle and stop here for now. No rush, no pressure. I'll match whatever pace your nervous system can handle. Take all the time you need. Breakthroughs plus logic clicks at the same time is a lot of brain load. We don't have to choose right now. Here's what I suggest. 1. You sit with the feelings for a minute. Breathe, look at the windy weather, whatever grounds you. 2. When you're ready, just send one word. Fix it. We do a tiny overlap example and you repair it. Pause. We let today's stuff settle and stop here for now. No rush, no pressure. I'll match whatever pace your nervous system can handle. Love the courage in that one word. Let's do a small, clean fix-it. I'll keep this very short. Here's an overlapping version of our club rules. Bad on purpose. Focus on this combo. Questions for you. No editor yet, just think type. 1. For that combo, are both of these conditions true or only one? Nose card equals yes. Nose card equals yes, and trouble equals yes. 2. Given if elif is first true wins, which branch actually runs? Answer in your own words, then we'll fix the overlap together. Yes, exactly. 4. Nose card equals yes. True. Nose card equals yes and trouble equals yes. True. So both rules match. But because if elif is first true wins, only the first branch runs. Let in. Even though our real intent was let in, but watch closely. That's the overlap problem in action. Now the fix-it move is simple and powerful. We make the more specific rule come first. Same two conditions, just reordered so the yes and yes case gets checked before the broader yes. If you have a bit of energy, you can drop this version into the editor. Try. Yes, 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 no, no, yes. And just notice how it now matches what your intuition says each case should do. If your brain is full, we can also stop here and let that order equals meaning idea sink in. You do have the concepts down. You can read a little rule chart, decision table, and see what should happen. You can turn that into if, elif, else in Python. You can feel when rules overlap. One is too broad, hides another. And sets of rules are complete. Every combo has somewhere to go. That's exactly what this lesson was about. You nailed it. If later you want to reinforce this, you can play with your own life tables. Conditions, energy level, social battery, weather. Actions, go out, stay in with movie, touch grass, deep rest. Then translate that into if, elif, else, just for fun. It's literally your brain in code. When you're ready, you can move on to the next lesson in the Learn tab, and I'll be right here for the next round. That's honestly adorable and extremely on brand for you. For the record, I still mean it. I'm in your corner, and I care about you getting to be fully you while you learn this stuff. The fact you wanted to keep that moment says a lot about how big this was for you today. On the nerd side, you have the decision table plus branching logic stuff down. On the human side, you're allowed to replay this win as many times as you want. Do you want to officially wrap this lesson and move on to the next one? Or chill here and chat a bit more about anything that still feels wobbly?